Hello, Assalamualaikum warahmatullahi wabarakatuh. Welcome to our group project presentation 1, which is titled Measuring Compression Pressure During Steel Tube Bending, Part 1, Transducer. This is our group, which is Harith, Taufiq, Muhammad Hafizuddin, and Muhammad Aiman. Let's start off by today's focus. We start off by introduction, basic operation, working principle, types of transducer, and characteristic of transducer. First, introduction of steel tube bending. Steel tube bending is a process used to reshape steel tubes into specific angles and shapes without losing its structural integrity. This bending process typically require high accuracy and are used in application where maintaining the structural integrity and exact specification of the tube are essential where the pressure transducer is used. Types of steel tube bending is rotary draw bending, roll bending, compression bending, and stretch bending. Okay, and the next is rotary draw bending. Tube is drawn in around a fixed radius die for smooth and precise bends. Transducer monitors the pressure applied by the bending machine to the tube as it is drawn around the die and ensure uniform bending and detect excessive strain. Second is roll bending. Tube passes through roller for large radius bends and coil. Transducer measures the force applied by the rollers on the tube to achieve the desired bend radius. Ensure the tube conforms to specific without exceeding strain limits. And third is compression bending, clamping one end and compressing around a die for larger ready bends. Transducer monitors strain during bending, optimize applied force, maintaining structural integrity. And the fourth is ram bending. This process involves using hydraulic or mechanical ram to apply force directly to a section of the tube, causing it to bend around fixed radius.
So these are the four types of steel tube bending that was explained just now. So firstly is the rotary draw bending, which the steel tube will go through a die and we bend with a bend die. And secondly is compression welding, where the steel tube will be bent with a bend die too with compression. Thirdly is the ram bending, which involves two counter rollers for us to bend the steel tube. And lastly is the three roll bending, which involves three counter rollers. So, what are the procedures of steel tube bending and how steel tube bending is done? First, the steel tube passes through multiple rollers and force will be applied to the steel tube with a rocker arm. And the amount of force applied by the rocker arm is measured by the transducer. So it is important for us to have the transducer to have the accurate measurement. So each transducer will have its own data logger and keep track of the force applied. The amount of force will be adequate when the steel tube produced has a uniform and neat surface. So this is a diagram showing the procedure of steel tube bending. We have two scenarios here. One is ram die and the other one is compression bending. So we can see that both process involves a flex sensor, which is a transducer, so that we know how much force is applied to the steel tube. So moving on, this is our selected transducer, which is HBM U9C. And HBM U9C is a strain gauge based force transducer, which is very applicable in steel tube bending. And strain gauge force transducer are widely used in various applications, and it is very accurate, reliable, and versatile. So what does HBM U9C offers? Firstly is accuracy and precision. It will ensure that the force measurements are reliable and can be trusted. Secondly is versatility, because it is capable of measuring a wide range of forces, big magnitude and small magnitudes, and it is adaptable to different tasks in the industry. Thirdly is the durability, because the design it is designed to last in challenging environments, and it will reduce downtime and maintenance cost. Lastly is the compact size. So HBM9C is a very small transducer, and it, because it is very small, it will be easy for us to apply in the steel tube bending. So here are the specifications of the HBM U9C force transducer. Firstly is the measurement ranges. So there are various measurement ranges for this transducer, which are 50 Newton, 100 Newton, 200 Newton, 500 Newton, 1 kilonewton, 2 kilonewton, 5 kilonewton, and 10 kilonewton. And for the accuracy class, this force transducer falls into the high accuracy class, which is 0.2 or better, and this means that it has a very low margin of error, and provides very precise measurements. And for the output signal, it is typically in the form of millivolts per volt, and the output signal for this transistor is 2 millivolt per volt. For the non-linearity, it is very low, often within plus minus 0.1% of the full scale, and this ensures that the output signal is proportional to the applied force. And lastly is the temperature effects, which is how the temperature affects the performance of this transducer. So the temperature effect on zero is typically plus minus 0.01%, which is very good. And the temperature effect on sensitivity is also 0.01% plus minus. This means that temperature does not affect much this force transducer. So this is the circuit of the transducer, which is a Wheatstone bridge, and there are 4 strain gauges in order for us to measure the force applied. So now we head towards the working principle of the transducer. So the U9C miniature load cell is designed to measure force or weight, and the application is the strain gauge technology, which is very available in a very small size, and due to its very small size, it will be able to detect very small changes, and it is often due to deformation. So the deformation will stretch or compress our strain gauge, and will change the resistance for the circuit, and this circuit will have different output of signal, which we need to condition, because the output of signal will be very small. It will often be like millivolt, which cannot be detected by a multimeter. So the output signal needs to be conditioned, and we need to calibrate for its accuracy. And how do we detect the force, you may ask? The force will be detected by the deformation, which I just said just now. So when the force is applied, there will be deformation that acts upon the material, which will change the resistance of the strain gauge and will affect the output. And the transducer uses a Wheatstone bridge alignment or circuit design, so that the configuration will be able to measure resistance throughout the material, and it is much more accurate. So this is a Tinkercad diagram of how the circuit is for the transducer. So the black area is where we apply the steel tube to measure its bending, and the transducer is connected to the Wheatstone bridge, and the change of movement, which is caused by our force, will change the resistor value and will affect the output, which we will calibrate into a signal output.
Ensuring accuracy of the transducer. There are 5 aspects that we need to see to ensure the transducer is accurate based on the reading. First is proper installation. The placement and install transducer at the key pressure point. Secure mounting by ensuring stable and secure the mounting. Protection shield from dust, moisture and temperature changes. Next is calibration. Initiate calibrate by using a known pressure sources at the steel pipe. Regular calibration and recalibrate periodically. Zero balancing by set to zero before each use. Next is data acquisition. Quality equipment by using precise amplifier. Digital filter to remove the signal noise. Sampling rate to capture detailed pressure variation. Fourth is monitoring and control. Real-time monitoring, track pressure continuously. Alert by setup notification for pressure deviation. Feedback, adjust bending parameters dynamically. Last but not least is maintenance. We need to inspect the next is maintenance. We need to inspect regularly to check transducer and connection. We need to clean connection to prevent signal loss, and we need to replace any as needed by swap out worn or damaged transducer. How to select transducer work in steel bending. First is mounting. The first transducer is mounted at the point of bending to measure the force applied to the tube. Next is real-time monitoring. The transducer will continuously measure the force applied to the tube. Next is signal processing. The processing data is logged off for the analysis. Specialized software to analyze force data to ensure the bending meets the process requirement.